8-48, it says a team of 8 students has finished an investigation on the many uses of parabolas. They must select a single group member to present their findings to the class. They have only a single coin to make chance selections, but they can flip it as many times as necessary to fairly select a student. Using a single coin, describe a fair way to select the presenter. So these kinds of problems, they're just, the answers are like, it's going to say answers may vary. That's pretty much, you can answer it any way you want, as long as it kind of makes sense. So if I have 8 students and 1 coin, here was, I erased it, but here was my idea. My idea was to just split the students into 2 groups and then do it like, just split them in half and then do a coin toss. And then like we'll say, let's say heads stays, tails is out, it goes. Okay, so we'll do like a elimination. So we just need 1 student to present, but there's 8 of them, and they all want to. So we're trying to see who's the lucky student that gets to present, or maybe it's the unlucky student who doesn't get to present. So you flip the coin. Heads, they stay, and tails, like you ask them like, what is it, heads or tails, like each team. And so whoever wins the coin toss stays, and whichever team loses goes away, so they're gone now. So then you have these 4 kids, and they're like, yay, we won the coin toss. Well, then split them into 2 groups again, and ask the one group, what is it, heads or tails? Or no, actually, just they do a coin toss. And so whoever wins the coin toss, I guess, gets to stay. So, darn, this group lost the coin toss, so they're gone. And then you can just do a coin toss with between the 2 students that are left, heads or tails. And then one of these 2 students is going to be the lucky winner. So it's just, I mean, that was just what I thought of the answer book, and maybe that doesn't make sense, but it says answers may vary. So you can say it however you want. This one says students could be paired and the coin tossed for each pair. So that's a little different than what I did, but you could still, pair it, and then all the 4 winners, because there'd be 4 pairs, all the 4 winners get paired, and they toss again, and they just keep kind of like getting eliminated until there's 1 left, and that's the same idea that I did here. So you can just write it up however you want. It's answers may vary. So that's the answer. The answer is that answers may vary. And then letter B says, what is the smallest number of coin tosses needed to select a presenter fairly? Describe the method. So I think my method, it would only take 3 tosses. So I would write 3 tosses. And then if I have to write it out in words, I would say, I'll write it with this so you can read it. Trying to focus the camera. I would say split the group in half and do a coin toss. So that's 1 toss. Then split the remaining group in half again and toss. So that's 2 tosses. Then split the remaining, because the first time you split them in half, there's 4 on each side, and so you eliminated 4 people. So now the second time you split them in half, there's only 4 people, so there's going to be 2 on each side, so 2 get eliminated. And then the last toss is going to be just between 2 people, the 2 people that are left. So split the remaining group in half again and toss. Oh, oops, that's 3. So that's 3 tosses. Your answer book says 3 tosses. You can actually do it the way the book says if you want to. You can toss the coin 3 times. Tossing a coin 3 times has 8 equally likely outcomes. So it can go heads, 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 tails, heads, tails, heads, heads, tails, tails. Anyway, there they all are. And you could do it that way if you wanted to. But my way works too because I only had to do 3 tosses. And then letter C says, 2 of the group members realize they'll not be in class the day of the presentation because they're playing in a baseball tournament. Can a presenter still be chosen fairly with a single coin? Explain why or why not. I'm going to say yes. I tried it just to make sure. I'm going to say yes. Split the group in half. And do a coin toss. So if I split the 6 in half, I do a coin toss, then I've only got 3. Now this is kind of weird though. I've got 3 kids left. So then, the first coin toss, I'm gonna have 3 kids in each side, and it's gonna eliminate 3 kids. The second coin toss, I'm just gonna grab 2 of these kids and coin toss, for them. So, toss for a pair of the remaining kids. Okay, so if I toss for a pair, one of them is going to be the winner and the other one's going to be the loser. So somebody's going to go away. Now there's only going to be 2 kids left. Then toss for the 2 remaining kids. So you can make it up however you want. You don't have to do it the same way I did it. The book says use the method outlined in Part B repeatedly until a baseball oh, am I on the wrong problem? 6-4A. I'm not sure why we're talking about baseball players. I thought we were talking about people that investigated. Yeah, I think there's like a little bit of a typo in your answer book because this problem isn't about baseball players. But you can just do it like I did it. And that's it.